Hi, this is Swati and today we'll see about rational numbers of class 8th maths. So before moving to rational numbers, this is very new to us. What are rational numbers? We don't know yet. So let us start with what topics we know, what kind of numbers we know. We'll start with that and then come to the rational numbers. Now in this video, I'll complete all the introduction part of rational numbers chapter 1. After that, you will find the questions easier and you would be able to do it easily. So let's get started. Firstly, what are natural numbers? We start naturally when we start counting naturally. It starts from 1, 2, 3, 4. So natural numbers are the same 1, 2, 3 and so on. Now coming to whole numbers. In whole numbers you can see it is 1, 2, 3, 4, but 0 is missing. So whole numbers start from 0, 1, 2, 3 and so on. Now, what are integers? Integers are a combination of natural and whole numbers. So, we anyways have 0, 1, 2, 3, 4 and so on. Along with this, we also have negative numbers which are less than 0. So, basically, I'll write here -1, -2, -3 and so on. So, integers are a set of positive and negative numbers including 0. Now, coming to rational numbers. Rational numbers are basically if I take 4 by 5, 3 by 2, -1 by 3. So, rational numbers are in the form of P by Q. We will see that now. So, before that, I will tell you that whole numbers consist of natural numbers. Now, integers consist of whole numbers and natural numbers. Similarly, rational numbers consist of all these. Rational number consist of natural numbers, whole numbers and integers. Now, what are rational numbers? So, rational numbers are in the form of P by Q, where P and Q are integers which can be positive or negative, and Q is not equal to 0. Now let us take 2 by 3, -1 by 2, 4 by 6. All these are rational numbers because they are expressed in the form of P by Q, and Q is not equal to 0. Now, just in case, I think, is 2 a rational number? 2 is a natural number. It's a whole number. It's an integer. It is also a rational number because 2 can be expressed in the form of 2 by 1, which is P by Q form. So, all the numbers that we know till now are known as rational numbers. Now, moving on, in this chapter we have some very important properties. We have some 5 to 6 properties based on which you will have questions. So let's start with first one, closure property. Now, when two real numbers, what are real numbers? Real numbers are all the numbers that we know. So it is natural number, whole number, integers, rational numbers, everything is a real number. A and B are added, subtracted, multiplied or divided. The result is also a real number. Now this means that suppose I take 2 and 5. So 2 plus 5 I get 7. Yes. Suppose I take 2 and -5. 2 minus 5 is -3. Okay. So whatever kind of numbers I take, add, subtract, whatever numbers I take, when I add those numbers, I end up having the same number. Now, for example, 2 and 5 are whole numbers. So when I'm adding two whole numbers, I end up having a whole number. Similarly, let us see for rational numbers, as our chapter is based on rational numbers. So, okay. So I'll take very easy numbers, 2 by 7 and 3 by 7. So first let me add them. So if I add them, I get 5 by 7. So when I'm taking two rational numbers, I end up having a rational numbers. So addition is true. Similarly, when I take subtraction, 2 by 7 and -3 by 7, I get -1 by 7. Again, when I'm subtracting two rational numbers, I end up having a rational number. Same with multiplication. Let's do 2 by 7 into 3 by 7. 3 into 2, 6, 7 into 7, 49. Same. Two rational numbers when multiplied, you end up having a rational number. Same with division. 2 by 7 divided by 3 by 7. Now, how do we do this? So, when we have division, we need to make sure that we will change the division sign to multiplication first. Obviously, if we are changing the division sign to multiplication, it completely changes the question. So the next fraction that we have, we need to write the reciprocal. Reciprocal means numerator comes to denominator and denominator goes to numerator. This is how you divide two rational numbers. So 7 gets cancelled and you end up having 2/3. So closure property is true for all addition, subtraction, multiplication and division. So basically when I add, subtract, multiply, divide two rational numbers, I end up having a rational number. Now next up we have commutative property. Now commutative property or commutative law explains that order of terms doesn't matter while performing arithmetic operations. So even when you interchange the position, the result doesn't matter is what it's saying. Now let us take two numbers. Let us take 4/3 and 2/3. So A is this, B is this. Now let us add. So basically this means that when I'm adding A plus B, and if I'm doing B plus A, I end up having the same answers. Now let us see if we are true. So 4/3 plus 2/3 is what? 4 plus 2 is 6/3. Now in the same way, if I interchange, now if I write 2/3 plus 4/3, I again end up having the same answer. So that means commutative is true for addition. Now let us try for multiplication. Same numbers, A into B. What do I get? 4 into 2, 8. 3 into 3, 9. Similarly, now B into A. Again, 2 into 4 is 8. 3 into 3 is 9. So yes, it is also true for multiplication. A into B is same as B into A. Now let us see for subtraction. Alright, so 4/3 minus 2/3. 4 minus 2 is 2/3. Now let us do B minus A. So 2/3 minus 4/3. Now 2 minus 4 is minus 2/3. So here you got 2/3 and here you got negative 2/3. So both are different. So it is not true for subtraction. If you interchange the values, the result is different. Now let us see for division. Division is 4/3 divided by 2/3. So we just saw how to divide. 4/3. You need to change the sign for division and reciprocate. So 3 gets cancelled. 2 ones are 2 twos are. So you get 2/1. Now similarly, if I try for B by A. So B divided by A. Now this time 2/3 into 3/4. 3 gets cancelled. 2 ones are 2 twos are. So here we are getting 1/2 and here we got 2/1. So basically commutative property holds true only for addition and multiplication. Even if you interchange the values, the end result is same. I hope this is clear. Now next one is associative property. Associative property states that the sum or product of three or more numbers does not change if they are grouped in different way. Which means, now let us take three numbers A plus B plus C. I am grouping B plus C first. And then I will check, I am grouping A plus B now. So when I group the terms differently, even then my end result is same. Now let us just see one example. Let me take the values of A, 2/3, 4/3 and 5/3. Okay. So now let us see addition. So 2/3 plus 4/3 plus 5/3. So I am grouping 4/3 and 5/3 first. So 2/3, as we know that the bracket part is always solved first. 5 plus 4 is 9/3 and then we end up having 11/3. Okay. Now I will group differently. Now I am going to take 2/3 plus 4/3 in one group. and then 5 by 3 separately. Alright, so 4 plus 2 is 6 by 3 plus 5 by 3. I end up having 11 by 3. So yes, when I'm adding with the different groups, I end up having the same answer. Now let us try for multiplication as well. So 2 by 3 into 4 by 3 into 5 by 3. I am grouping 4 and 5 together first. So I get 2 by 3 into 5 into 4, 20 by 3, which is equal to 40 by 3. Now the same way I am going to group differently. I am going to make 2 by 3 and 4 by 3 into one group, and I'll write 5 by 3 separately. So 2 into 4, 8 by, okay, here 3 into 3 is 9. I'm sorry, so this is 27. Alright. Okay, 3 into 3 is 9 into 5 by 3. So again 8 into 5, 40 by 27. I end up having the same answer. So which means that A into B into C is same as A into B into C. That means whatever way I group, I end up having the same answer. But now let us see for subtraction. So subtraction 2 by 3 minus 4 by 3 minus 5 by 3. I'm grouping these together. So 2 by 3 minus, now 4 minus 5 is minus 1 by 3. So we end up 2 by 3 plus 1 by 3, which is 3 by 3. But just in case I interchange the order. So 2 by 3 minus 4 by 3 is in one bracket and minus 5 by 3. So 2, okay. So here what do we get? 2 minus 4 is minus 2 by 3 and minus 5 by 3. So we get minus 7 by 3. So you can see that the end result is not same. Again, associative property is only true for addition and multiplication, and it is not true for subtraction and division, same like commutative. Now coming to the third property is distributive property. The distributive property tells us how to solve expression in the form of A into B plus C. Now A into B plus C. So here this bracket means it is multiplication, right? So this I can write it as A into B plus A into C. So A is multiplied with B as well as A is multiplied with C. Alright. Now let us take an example. Let us take 2 by 3, 4 by 3 and 5 by 3. Let us take same examples. Okay. So let us see. I end up having the same answer whatever way I do. So A into B plus C, what do we get? 2 by 3 into 4 by 3 plus 5 by 3. So generally what do? We do the bracket part first. So we get 2 by 3 into 4 plus 5 is 9 by 3. So 9 into 2, 18 by 3 into 3, 9. Now, but this one, the other, this is equal to what? A into B plus A into C. So if I end up doing this one, 2 by 3 into 4 by 3 plus 2 by 3 into 5 by 3. Now see what do we get? 2 into 4 is 8 by 9 plus 2 into 5 is 10 by 9. So we end up having 18 by 9. We get the same answer. So this is very important. This will be used in almost whole maths. Everywhere, whenever you see this algebraic expression, this is how you do. So this is very, very important. I'll just give you one more example. Now let us see. I have 2 2 into A plus 3B. Okay, a random example. So then this 2, the number that is outside the bracket, it needs to be multiplied by everything that is inside the bracket. So 2 into A is 2A, 2 into 3 is 6B. So this is how you do. When we do the questions, you will understand in a more clear way. Now next up we have additive identity. Additive identity, it has addition in it, right? The name itself has addition in it. Now any rational number plus 0, when you're adding 0 to any number, you end up having the same number because 0 has no value. So a plus 0 or 0 plus a is always equal to a. Now what is additive inverse? Additive inverse, you also have additive inverse. Okay, we'll see this later. Now if I take 73 plus 0, obviously my answer is 73. Or if I take minus 5 by 6 plus 0, I end up having minus 5 by 6. So when you're adding 0 to any number, you end up having the same number. Now additive inverse is basically a plus minus a is equal to 0. Now how do we find the additive inverse of any number? Let us take, I have a number 11. Its additive inverse is minus 11. Let us say I have a number minus 3 by 4. Its additive inverse will be plus 3 by 4. So basically to find the additive inverse, it is just interchanging the sign. If it is plus, put minus, and if it is minus, you need to put plus. So this is how it works. Now this means, why are we doing this? Because additive inverse is equal to 0, additive identity is equal to 0. So when a positive number and its negative numbers are added, the end result is 0. So that is why additive inverse of any positive number is negative. Additive inverse of any negative number is always positive. Now moving on, multiplicative identity. Okay, so here this is rational number into 1. It's error. Okay. Any rational number, when you multiply it by 1, you end up having a rational number. So for example, a into 1 or 1 into a is always the same. Here they have used commutative. Even if you interchange the position, your end result is same for multiplication. Now suppose I have 63 into 1. I get 63. I have minus 111 into 1. Again I get 111 minus 111. So any number, when you multiply by 1, you end up having the same number. Now what is multiplicative inverse? What is multiplicative inverse? So this is basically a into 1 by a is equal to 1. Now let us say I have a number 3. Its multiplicative inverse is going to be 1 by 3. This is known as reciprocal. What is reciprocal? When we interchange the numerator to denominator, denominator to numerator. Now let us say I have minus 4 by 5. Its multiplicative inverse is going to be 4 by 5. The signs will be there. Only thing is you will interchange. Numerator comes to denominator, denominator goes to the numerator. No happening with signs, nothing happening with signs. Whatever sign you have will be there. So this is multiplicative inverse. A into 1 by a. 1 by a is the reciprocal. So when we do multiply a number with its reciprocal, the end result is always 1, which is multiplicative identity. So in short, additive identity is 0 and multiplicative identity is equal to 1. So these are some of the properties of this chapter, rational numbers. So if you're good with all these properties, we will be doing the next video on questions on this chapter. The most important and repeated questions, I will make a video. I hope you liked it and enjoyed it. Please subscribe for more such content. Thank you.